So my name is Keenan Turner. I'm the Business Development Manager for Sirewall. And so for those of you that aren't sure what Sirewall is a high-performance structural wall system that's based on the original idea of an insulated rambert wall system. So Sirewall actually began back in 1992 by Amir Kranhoff, who's our founder and CEO. For those of you that want the spelling, that's M-E-R-O-R. Now, Amir's been at the forefront of environmentally responsible construction, alternative materials, and energy systems for over 30 years. This is a man that built a 100% recycled home in 1975. Of course, it was shaped like a boot and floated on a river, but in the 70s, I heard that's not too weird. So in his journey to find a better way to build, he realized that trying to fix the current way we build would only bring more of the same issues, and began what it would be like if he started to explore the possibility of starting fresh, from absolutely nothing. So, for example, if I were a being that came here from another planet and just landed on Earth, given that there was no current paradigm for construction, what would I see, what would I do? So standing there, in the middle of a field, looking around, just arriving on Earth. Well, I would see grass, I would see trees, rocks, sand, water, clouds, mist. Well, what are the parameters for the structure that I want to create? Well, I would want it to be healthy. I'd want it to be durable, warm, all those things. So given that now you have the parameters, you can start to experiment with the readily available materials around you. It was this kind of thinking that brought about Sirewall in the beginning. Now, there's a quote that I'd like to share with you that's often misattributed to Charles Darwin. It is not the strongest of the species that survive, nor the most intelligent, but the one that most responsive to change. Now, before any change can occur, it's important to distinguish the current reality that you're changing from. To do that, I'm going to make a presentation called the Stinky Jar. This is from day one of our Introduction to Sirewall course that we offer on Salt Spring Island. So up here you see, we have a picture of this you'll find in a lot of convenience stores and grocery stores around BC. And it basically says that formaldehyde is bad. So, poison, skull and crossbones, it's a pretty clear picture. So now we're going to move to scorecard.org. This is taken from Good Bad Incorporated's website, scorecard.org, which is a fantastic organization, fantastic website. And I just found out that they do have an app for that, if you got that phone, so you can actually scan products and they will give you their health, environmental, and societal impact rating. These are currently for US products, but they're always building the database. But highly recommend it. It's a fun new toy to go around and scan things in the grocery store with. All right, so all of this came out of Proposition 65 in California. And I'm not sure how many people are aware of what Proposition 65 is or was. And I know I didn't before becoming involved with Sirewall. So it's a proposition that passed in California where, paraphrased, it said that if a manufacturer creates a product they know could be harmful to people's health, they have to advise them of that, or they're culpable. So if they didn't tell people that their product is harmful, they get sued. So it encourages manufacturers in a very effective way to reveal the health risks of their products. The CMA, or Chemical Manufacturing Association, they really didn't like that too much. So the same proposition that was proposed in 3 other states, the CMA ran a confusion campaign and it did not pass. So our company does a lot of research into every material that we work with on-site, off-site, and when you look at material safety data sheets, the MSDS, on a certain product, it might say that it has some mild health effects, or that it could possibly cause problems. But in California, it's a known carcinogen and has a ton of nasty side effects. So this is all because of Prop 65. Anyways, I'm going to read to you what they say up in there about formaldehyde. So it's a recognized carcinogen, a suspected gastrointestinal and liver toxicant, aminotoxicant, neurotoxicant, reproductive toxicant, respiratory toxicant, skin or sense organ toxicant, and more hazardous than most chemicals in 7 out of 12 ranking systems, and ranked as one of the most hazardous compounds in the worst 10% to ecosystems and human health. So, formaldehyde, bad. So now I'm going to ask you to use a little bit of your imagination. First of all, I want you to imagine that this table is an island, and that this is going to be a typical North American house. So when most houses get built, they get built off of a foundation. Now, in that foundation, usually what you'll find is you'll find a grid of steel mesh, wire mesh, could be a 6x6 remesh, 10M rebar and reinforcing pattern through stem wall or footings. So the first thing that goes in is steel. Now the benefit of doing the work that we've been able to do and with the clients that we've had, we've done some work with a lady by the name of Katerina Gustavs. Katerina is a bow biologist. And bow biologists, what they do is measure the invisible world, or the things that the rest of the world has a lot of trouble quantifying. So, or often we're just unaware of them. A couple examples of Katerina's expertise is the study of magnetic and electrical fields. And when we put a steel grid between ourselves and our planet, we're disrupting the geomagnetic field, or the planet's magnetic field. There's a general perception, too, that this magnetic field is constant. However, it's actually constantly shifting. That shifting is called Schumanns Resonance. And that resonance can be called nature's GPS. It's what guides the geese on their migration, the salmon back to their spawning grounds, tells the squirrel to pack up for winter, and also, if you put it on a homing pigeon, guides it back home. Now, if you put a magnet on the back of a homing pigeon's head, it will not find its way home. So people also have historically been guided by Schumanns Resonance. And of course, over the years, we've distanced ourselves to the point now where we only think we have 5 senses. And actually, a funny thing that Mir did for a while, he carried a compass around with him in his pocket. So when he went inside of spaces, he'd go in and see, where's north? So he'd walk in there, he'd pull out his compass, point north, and it'd be north, and north, and north, and north, all the way around. So the interference between the building and the earth had actually pulled the pointer directly down in the compass. There was even one building that he went into and it was just spinning, just like this. So I'll let you speculate on what that means. Now we as humans, we're not physiologically much different than we were about 400 years ago. Say if I had the ability to pick somebody out of the year 1600, shave him, give him an update in his hairstyle, slap a name tag on him and put him in this room, you'd be hard pressed to point him out. So my point is that we've had a lot of environmental changes over the last 400 years, but our physiology is not one of those things that's changed very much. My point is people don't adapt to these changes quickly. We're not insects. So the first thing that happen is you put the grid in. Once the grid goes in, now the grid goes in into a concrete foundation of which you build your house on. And this is poured into a formwork made of plywood. And typically on this plywood, they'll either use diesel or a commercial foam release agent. Both of these products have volatile organic compounds. Volatile organic compounds are carcinogenic and can cause cancer. And if you notice, I mean, something that actually I point to right now is something that happens inside of homes, which most of you I'm sure are aware of, is called the stack effect. Now, for those of you that aren't clear, I'll do a short demonstration on the stack effect. So say outside air, which is fairly constant outside of the home, let's say it's about 1 atmosphere. And inside the house, because it's a contained vessel, let's say it has 2 floors, from the bottom floor, heat rises, and the air pressure will be higher at the top than the second floor. Maybe it's 1.1 atmospheres at the top. It's about 0.9 atmospheres at the bottom, and the difference in air pressure causes the air to go to the top. Well, at the bottom, it is pulling the air in. That's the stack effect. So anything that you have at the bottom of your space, inevitably, is going to come through your building and into your living space. So when you're putting VOCs, volatile organic compounds, or foam release agents onto your concrete footings, that is going to end up inevitably inside of your space. Now after the concrete gets poured, the walls will go in, sill plates go down, and of course there are a number of alternatives now, but we're going to use CCA treated lumber as an example, which is copper, chromium, arsenic, and that's a toxic material. It's arsenic. It's fairly standard, you can look it up on scorecard. So the sill plate goes down, and if you're doing your renovations, you'll notice that decay always happens at the base or near the concrete in any stick frame structure. It's because that's where most of the moisture gathers. So what happens is, we toxify these sill plates to the point so they don't act like an organic material. The principle of organic materials in residential, not just residential, but in construction, particularly lower grade, is that we have them toxified so that they don't perform in an organic way. So because organic materials are designed by nature to decompose. It's a fundamental, foundational principle that organic materials are designed by nature to decompose. So we toxify them. So the first thing that happens, your sill plate goes down, the house gets framed, and the lumber that you buy from the lumber yard is typically covered in fungicides. A, because it's very hard to sell black lumber, and you don't want your lumber molding right away anyways. Now anything that ends inside is typically not a good thing. Genocide, homicide, fratricide, producticide, so all means death. So you've got your side, you've got your fungicides on there, you've got your sill plates with arsenic, and that's that. Now what happens is you're starting to get a picture of what the building's looking like, and your electricians come in. You've got to have lights and everything. Now if you look at what wire is, it's a flexible plastic. Flexible plastics are flexible because they have the addition of phthalates. Phthalates is a funny little word, P-H-T-H. And phthalates are an endocrine disruptor. You can take a look at it on scorecard. It's wonderful. There's all sorts of parental advisories that are out right now telling you to avoid buying soft plastic toys for your children because of what they do. So, and in the outer sheathing actually, where there's additional phthalates, they've also provided that they put lead into the sheathing as well. Now something that happens with lead in there, is we were talking about decomposition. Everything decomposes, and the lead in that ends up in the dust that's all around all your wire. And what's happening with a lot in the United States, especially, with the housing stock going down and copper going up, people are stripping houses that are up for demolition or abandoned. So when they're stripping out this wiring, the decomposed wire that's lead in the dust, they're ripping it out, the dust is getting kicked up, and they're sucking in all the lead. So there's a lot of lead poisoning going on as well. So that's the wire. I want to go back to Katerina Gustav's for just a second. We talked about the magnetic fields, and now I'm going to talk about the electrical fields. Now when you wire a house, typically what you'll wire is about a foot off the ground. You have your wiring, starts at a plug, moves on to the next plug, then it'll move on to another plug, up to a light switch, over a doorway, and it continues all around your house. That's how they do it, goes through all the steps. Now if you were to wire a home so that you got the maximum amount of exposure to electromagnetic fields, Katerina says that's the perfect way to do it. All right, so next we're going to have the floor joists. Now floor joists used to be that they were solid wood covered in fungicide, which we've already touched base on. But now what we have are TGIs, or joists that have OSB as the web. You used to be able to get them with plywood, but not that I'm aware of. So this OSB, I don't know if you're familiar with OSB, but it is a nasty product. So what it is it's a lot of wood fibers. They use a large amount of urea formaldehyde to hold them together. And if you go into a new house that's just been framed and you don't know what urea formaldehyde smells like, that's it. So you got your 2x3 top and bottom covered in fungicides, and of course you've got your urea formaldehyde lace spreader. So when you get to the outside, the walls are up, you get to the outside, you're usually covered in OSB as well. But a better quality house will use plywood. Now, plywood itself, typically how they do it is it's small strips of rubber that is placed this one sheet this way, glued another sheet this way, glued another sheet this way, alternating grains to increase its strength. Now, what they use to glue these fiberboards together is a phenolic formaldehyde. Now, phenolic formaldehyde is the same family as formaldehyde, and they only use 5% of the glue in plywood as opposed to OSB. So it's definitely a less bad product. And it is a less toxic glue, phenolic formaldehyde versus urea formaldehyde. So I say less bad because it's still toxic and still has negative health impacts. So there's a common misconception that I'm just going to take a moment to clarify. So there are three things that have broad misunderstandings. One of them is that things are stable. Solids are solids, liquids are liquids, gases are gases. Whatever's on this surface here isn't going to affect me. It's solid. It stays over there. That's there, and I'm here. You're all sitting out there, I'm over here. I'm not consuming it, you're not consuming me, anything else. When in actual fact, we're all consuming each other. We're all decomposing around us and our environments. And we're breathing in, a big part of us is people decomposing, consuming each other. And there's actually been a study done, the result of which was that we inhale 1 atom of Mahatma Gandhi and 1 atom of Adolf Hitler every day. So there are many well-documented examples of whatever chemicals you're using in your home and around you, and we're decomposing. Again, we say it's over there, I'm not consuming it, when in fact you are. The fact is we consume 54 pounds of air, 5 pounds of liquid, and 1 pound of solids every day, on average. What we tend to focus on, though, is eating raw, vegan, organic, whatever your choice is. And that's great. But if you look at that, our body, the same body that's been around for however many eons in this form, has a lot of filters, organs, kidneys, rapid evacuation, should it be necessary, in order to get rid of all of these things that we ingest. If you look at how when we're breathing in something, we have very limited filters. We're looking at mucous membranes and some little hairs. Other than that, it goes directly into our lungs and right into our bloodstream. This is the main line right into our blood. Now again, we focus on that, even though that we're breathing in 10 times more than what we're eating, we're focusing on our food. Which again is great, but it just seems to be a little bit less than something less to me than something we're mainlining. Anyways, back to the house. So, next step is insulation. The most popular is fiberglass insulation. So the manufacturers claim it's green because the glass is recycled. However, the glass fibers are glued together with urea formaldehyde, and it's already been determined that the fibers are carcinogenic. The second most popular insulation are polystyrene foams, is your blue or your pink board. These are not good if they burn. They release dioxins and furans. In order to combat this, they add brominated fire retardants. All of these are very nasty, and you can look them up on Scorecard. So when you look at it, there's also a blowing agent in here. I'll skip this part. HCF13A. And it, like all materials, has a GWI, or a global warming impact. The GWI for XPF is 1,430. That means that it is more damaging, 1,430 times more damaging than carbon dioxide. There's a great article on insulations by Alex Wilson of Green and Building Advisor, and greenbuildingadvisor.com, where he looks at the life cycle impact of each insulation. Alex states, by comparison, if it's XPF you're adding to the 2x6 wall, the payback for the added insulation is much longer. Adding 1 inch has a 36-year payback. 2 inches jumps to 46 years. 4 inches is 65 years. And if you go to 9 inches, or go for an R60 wall system, you're looking at a payback of 110 years. So from a global warming perspective, you're better off to uninsulate your house and leave the heat on for 110 years. All right, and because we're building in British Columbia, the next thing that we're going to go on with the house is the vapor barrier. Vapor barriers, flexible plastic, so we know it has phthalates in it, and it has an acoustical sealant, which is tar-based, so volatile organic compounds. Mandatory for stick frame construction in British Columbia. Oh, my favorite, okay. Drywall. So after that, the drywall goes on. Now, drywall, just to get a description of what it is paper, gypsum, glass fibers as a tensile member. Paper is covered in a fungicide. So now, one thing that's scary about the drywall now, that's more scary than it already is the fact that they're recycling fly ash into it. Fly ash is a product of all the coal. Now, recycling is always a good thing, better than going directly into the dump. But not a lot of people know what's in fly ash. They just think it's recycled, so it's got to be better. Well, it depends on the coal that's being burned. But very common for fly ash is to have mercury, antimony, arsenic, and many other heavy metals in it. So that's going directly into your wall system now. And we have, at Sirewall, we have top 3 most scary products. Drywall is one of those. It's not so bad once it gets wet, it's a mold factory. So like I said earlier, all organic materials are designed by nature to decompose. And one of the great agents of decomposition is mold. Molds love it to be wet as well. They need it to be above 65% relative humidity to reproduce and survive. And they love cellulose, paper being one. So now if you get paper and you make it wet, that's the perfect environment for a mold spore. If you hide that wet paper behind some baseboard, where it's never going to dry out and it has this entire sponge of gypsum, well, that's going to stay there and it's going to stay wet and it's going to emit an enormous amount of spores. That's one of the great capabilities of molds. You can go from 1 to 1 million spores in 24 hours. That's the drywall scene. So next, after you have the drywall, you have tape. On top of there, you tape the seams up. The paper has a carcinogen in it. And then you also have mud. And you don't want mud to mold or anything else, so you put urea formaldehyde in it. Urea formaldehyde is cheap, sticky, and prevents things from molding. So it's used in abundance in construction. And I hear this is making a comeback, though I'm not sure why. Wallpaper, vinyl, phthalates, binders. And on to the next. Now here we have paint. Paint is one of the greatest greenwashing stories of our generation. And what you'll see is you'll go into a store and you'll see low VOC paint or no VOC paint. Now the definition of a volatile organic compound, or VOC as far as paint is concerned, is something that combines with ozone to create smog. That's what a VOC is. So that was the original definition. And if you go to the EPA or the Environmental Protection Agency website, you can get an entire list of thinners that are VOC exempt. So it's possible to have a 0 VOC paint but has ammonia in it, or has acetone in it, or it could have dimethyl, buty, trioxy, whatever, chemical strength. But that's all VOC exempt. So the dilemma with paint is you want to get a color on the wall and you want it to dry quickly. So therefore water doesn't work. It takes too long to dry. So you want something that evaporates more quickly. As soon as you want something that evaporates more quickly, it becomes volatile. So if you look at a no VOC paint using a VOC exempt thinner, like ammonia, then they would have to cover it up with an odor inhibitor. And VOC, yeah, so those ones are, I lost my place here, 1 second. Inhibitors, so you won't smell it, and then they can still advertise it as VOC free. Odor inhibitors and dryers and paints are not controlled. So again, they're not on your VOC list. So the result is basically a more toxic paint that's 0 VOC. The same can be said for the water-based paints. They were great for a while because they were healthier, but they weren't as good performing as the oil-based. So they've now added more chemicals from the VOC exempt list so that they perform equally, but have lost the overall impact of being healthier. Okay. Now we're going to move on to the kitchen cabinets. I'm not going to go into these too much because we've pretty much beaten the MDF and OSB to death. So we've got melamine in this one, and MDF, medium density fiberboard. Again, primarily a lot of urea formaldehyde as the binder. Put together with that. And I know about cabinets from the construction that we've done that you're looking at a half-life of 4 years. So you're looking at your initial outgas rate, 4 years before it's half that. 4 years before it's half that again. So you're looking at a long time before that stops off-gassing into your space. Missing that. Anyways, we have vinyl flooring, which is a flexible plastic. They use it on countertops. I remember walking in and thought I was looking at a slate countertop, but it was actually vinyl. Vinyl contacts, flexible plastics, we know has phthalates, carcinogenic glue in it as well. And I mentioned earlier that we have our top 3 nasty products. So drywall was one, kitchen cabinets, the MDF or melamine was another. The next is carpet. So carpet, we'll start with the underlay actually on carpet. So when you look at the underlay in carpet, it has an initial outgas rate, just like all materials do. What the unique thing about underlay is that you'll find is it has an outgas rate that starts to go down, and at 5 years, it kicks back up to its original outgas rate, and then goes back down again. It's the only product that we've seen that actually does this. Now the carpet itself, or rugs, they're typically made, there's a grid pattern, it can be nylon, polypropylene, or jute, and the fibers are either looped around, kept looped like this one, or they're cut off and extended out. And they're glued most likely with any of the cheaper carpets with urea formaldehyde. But if you do any research into it, the carpets, the backings, and the pads all have hundreds of chemicals in them that have their own environmental and health impacts. All right, so we got the carpet in there, and it's almost time for the people to move in. And of course, new houses, that's a big privilege, especially out here with the cost of housing. So and they're going to bring in all of their materials. So we're going to start next, they're going to bring in their fabrics. Now fabrics, they're all commercially made. If you get permanent press, non-iron, those kind of things, all have urea formaldehyde in it. Also your furniture has urea formaldehyde in it, your drapes have urea formaldehyde to make them stiff so they don't mold, and they also are covered in brominated fire retardants as well. Even pillows are, so you're sleeping on that. And then of course, the kids' toys, phthalates, soft plastic toys, and then you have your pets running around, all that kind of dander and dirt. And then they bring the appliances in. Now when you have appliances, you have a spinning motor, say like in a fridge. And that motor, the copper is rubbing against the armature. And when that happens, it's emitting ozone, which is a bronchial irritant. So that's also in space. And as a result of us building tighter and tighter houses, which allows us better control over the interior environment of our homes, the goal of shelter. But there are times when the tight house is so starved for air. For instance, when you have the clothes dryer on, you have the bathroom fans on, the kitchen range hood is on, and more air is exhausting out of the house and it's just sucking for air. And it has to get air from somewhere. One place in a lot of homes is from the chimney. So if you have a fireplace, or it can come through even on the water heater. So what happens is, as a product of combustion, you have carbon dioxide going up out of the chimney. When the house starts sucking air and bringing it back through there, that carbon dioxide comes back down, runs over the fire burns off an oxygen atom, and now you have a colorless, odorless carbon monoxide gas back into your space. We did research years ago on carbon monoxide and the carbon monoxide sensors. The best one at the time was called the Nighthawk, and it started to alert you at 800 parts per million. Carbon monoxide starts damaging human beings' health at 5 parts per million. So there's a large gap there. This came very clear for us when we were building a house for a neurologist out of Oregon, up here in BC. So what happened with him is he wanted a downdraft stove, so we didn't have to have a hood fan or anything. But it sucks an enormous amount of air out of the space. So Amir sat him down, explained to him about carbon dioxide and carbon monoxide, and having to get makeup air. So he said, you tell me how much it's going to cost and I'll decide if I want to do it. So we said it's going to cost him $1,500. He said no. So very rarely when we're dealing with clients do we put our foot down. But we said, you know what, if you're not going to put in this makeup air, you can have somebody else complete the project. So we're not going to read about you in the newspaper. He said, okay, if you feel that strongly about it, go ahead and put it in. We did a really good job of it. Even had the makeup care come on so it was exhausting into the refrigerator motor so it warmed up the air into the space and everything. 4 to 5 months later, he came back up from Oregon to his place. And he came in to see Mir, sat down and had a conversation with him. And he said that he had been referred 2 patients from another doctor that were exhibiting signs of Parkinson's. They had the tremors. But there was no Parkinson's in their blood work. So he referred them over to him. And this doctor found that they had low-level carbon monoxide poisoning in their blood work. And Mir asked, well, what's the result of this? Can you take them out of the home or get them more oxygen? What do you need to do to fix it? And he said, there's nothing you can do. It's permanent brain damage. So, a real sleeper that we've got an eye opener on. Back to the house. And I used to smoke a pack a day. Some people still smoke in their houses. So you go in there. And of course, your house, it stinks, so you can get air fresheners. And then, of course, your house gets dirty. So you got all your cleaning products and all those things under the sink there. So the code requires that from there, we seal it up really nice and tight. And inside that nice and tight house, every single person that's in there is exhausting 1 liter of moisture per day. Pets do, and then you've got toilets, showers, cooking, everything else is increasing the humidity inside of that house. And we can't forget that we've got to heat it up to a nice solid temperature. And that's the stinky jar.
All right, so we start with that.